All right, we're ready to begin. If everyone could sit down and cease the discussions or move it outside. So for our closing speaker, we welcome back Mark Sirangelo, the chairman of Sierra Nevada Corporation Space Systems. And to keep the introduction short, please join me in welcoming Mark Sirangelo.
Hi there. It's almost party time, right? I'm thankful for all you staying around and listening, and hopefully over the next few minutes we'll talk about. Excuse me. What I want to talk about is a little bit different than I think I've usually talked about. It's not really a report on the state of affairs in my company, although I'll mention that. It's really to talk about, in my view, what the next few years might look like, and if we can get. I've been spending a lot of time recently thinking about where we stand, where our place is in the industry, and where we might be going in the next few years. And I thought I'd just share a little bit of that vision and perhaps a few thoughts and my own point of view on things. We at Sierra Nevada, we do 4 things in space. We just finished our 430th space mission over our history, and about 4,000 things that we've built for space over time. And there are 4 things that we do. We are one of the largest builders of small satellites in the country and in the world. We are a significant builder of components and subsystems that enable other people's spacecraft, satellites, and spaceships. We build rocket motors that are being used by a number of different places, including our own. And we're the owner and operator of something we call the Dream Chaser, which is the orbital space transportation system that is currently in the competition for the NASA Commercial Crew Program, as well as a number of other missions and areas. And I want to use those as a base to talk a little bit more about the passion and the fun about being in this industry. I had the chance a little over a year ago to sit down and be the person who introduced the 50th anniversary of John Glenn's flight. And it was a very special honor for me, and I spent some time with John and Scott Carpenter, who were both there celebrating the 50th anniversary of being in space. And I'm not going to talk about John or Scott because I think everybody knows their history. But what I'd like to talk about, one of my favorite quotes is from Isaac Asimov. If I get to heaven, I really want to do what I'm doing right now. And I think after talking to John that night, as many of you know, he flew, and then he flew many years later when he's in his 70s, and I think he's approaching 90, and I think he wanted to come fly with me. And that was, to me, the really essence of what we are in this industry, the passion that exists in something like that. And he was very serious about it. We got to the podium, and he kept asking me questions, the technical questions. I want to make sure that he was going to be safe at 89 years old when we go fly together. And but it was a moment that I'll remember, not so much because of the pomp of the evening and circumstance of the evening, which was terrific, but because I think that's what I feel that hopefully someday I'll become, is to be able to look back on a career and say, I still want to do this, I still want to be passionate, I still want to go to space when I'm 89 years old. And I think he shows that, and he still shows that. He calls and wants to know when we're going flying and when the vehicle's going to be ready. And as a former U.S. Senator, he doesn't do that in a very polite tone. He's like... But I spend a lot of time talking, and one of the things I always try to mention is that we don't exist without looking back to the past. And for me, respecting the past is an important part of what we're doing. Our Dream Chasers really is, in our view, is the continuation of the shuttle program, not just technically, but emotionally, and with the spirit that exists there. In my view, 135 flights over 30 some odd years of shuttle. When it ended and it stopped its flying, what it meant didn't end. And it now is embodied in my program and the people who are behind it and other programs like ours, where we're continuing that particular spirit and that energy. And sometimes it's really interesting to look at life from a different perspective, and that's mostly what I'm going to talk about today. And as this is a space crowd, but oftentimes when I speak to people who aren't in space, one of the things they always ask is, why is the vehicle upside down? And one of the things we say is that there really isn't an upside down in space, there's just space. And I think when you look at life from a different perspective, it oftentimes changes the way you view the world. And one of my favorite photographs is this one. Bill Anders, and it was the first photograph of the Earth rising. And what was significant about that, I don't know how many people actually remember the background to this story, but it was really, from most people's point of view, the start of the movement that said we really have to take care of our planet, we really have to take care of what we're doing. Because for the very first time we saw this little fragile marble-looking thing sitting out there and realized everything we've ever known, everything we ever are, and everything we ever will be on this planet was encompassed in that little circle that he took when he took this photograph. And I'm sure he felt it when he saw it for the first time, but the only place you could take this is from coming around the moon. And that was a very special moment for him and I think for us in the country, because we began to see things from a different perspective, how things can really change. And I think we're at that point now in many ways. This is a conference about the next generation and where we're going and NewSpace, and I think we're at the dawn of many of those kinds of things. The building of spaceports around the world and the ability for people to go to humans in a way that we never did before. And if you could run this video, I think many of you have seen this, and it's a video of the first flight of Spaceship Two. And we're proud to be part of that program. We built the rocket motor that you will see here. And it's an amazing feat in many ways. It's the first time the motor is fired with pilots on board, the first time the spaceship took off. And we're on the runway watching this happen. And it dawned on me that one of the things that we really didn't think about, and it was almost an afterthought, was the fact that we went from a forward speed of not very fast to 1.2 Mach in little over 16 seconds. And we raised about 2 miles worth of altitude. And it took people flying many, many years to break the sound barrier. And we did it that day on our very first flight in a new spaceship, running a rocket motor for the first time that had been run. And that wasn't really the storyline. The storyline was about the fact that this could be the day where we see the beginnings of humans going to space in a different way, in a way that isn't all pure government or military. And one of the things that I talk about is the fact that in the history of space there's been something like 550, 60 people who've gone to space from all countries for the entire history of space. And Virgin and other companies, particularly Virgin, since I know them better, have more people signed up to go on this suborbital flight than have been to space in the entire history of space. And while that's a commercial statement, it's more about the fact that this is going to change the way we view things. It's going to change the way that the world looks. Much like that picture of the Earth was up there that changed the way that people looked at the Earth, I think we're going to have now not 5 or 10 or professionally trained people to go to space, but we're going to have hundreds, if not thousands of people shortly who would have seen what space looks like from a different perspective. And when that happens, I think that really changes the way that we're going to look at not only our world, but the way that we look at space. There's going to be people, it's funny because a lot of people think that the client lists that are going are all going to be wealthy people, and many of them are. But I've met a lot of them, and many of them are people who had that one thing that they wanted to do in life, that they saved up all their life for, and this was going to be it. They were going to spend, this was their retirement gift to themselves, this was their passionate gift to themselves, and they were going to go up to space. And you start really realizing that there's so many different kinds of people who are going to be there. I start wondering how that's going to change what the future of space is going to look like. And I know many of them. One particular person is a singer by the name of Sarah Brightman, who is on the list to go for Virgin, and she's now also going to be the next passenger to the International Space Station. And she is a professional, globally known singer. She's got a new tour out that's called Dream Chaser, and we're very proud to be part of this. But really what it's more about is someone who, when she was 4 years old, wanted to go to space and be part of this. And now these kinds of people are going to be up there and they're going to be bringing art, they're going to be bringing history, they're going to be bringing different kinds of backgrounds to space in a way that it's never been done before. We're a big builder of satellites. And I talk a lot about the hardware, and most people are going to see the shiny hardware and the great things that I and other companies are building. But it's really not about the hardware. It's about what you do with the hardware. And I talk about this in the terms of what I think we're building, the infrastructure that allows this to happen. The next generation of people are going to build the apps for that infrastructure, no different than what we're doing with our iPads or our tablets. And I think we're at the point now where that's going to start making a difference. And I can go into several dozen of what those apps might be like, but I'm going to choose just one to give you a sense of what I'm talking about. through a lot of satellite technology, and whether or not you believe in global warming or not is really not the issue. What is the issue, and what's the interesting opportunity, is the fact that the Earth is getting warmer, and I'm going to take something that we're going to do here in a few minutes, which is drink some wine, I think, and realize that what's going to happen is the wine industry is going to shift. It is already shifting. And the apps that come out of space, it's not about the satellite. It's about the fact that somebody is going to realize that Napa Valley very shortly, if you look at this research, you can't really see the colors, but the red right now is where wine is. The darker color is where the wine industry is going to be in 20 or 30 years. Because the way that vegetation is moving, the way rain is moving, the way the sand is moving, I have some background in the wine industry, and people are starting to think differently. And I say this, that we're probably going to have good Montana wine not too far in our distant future. And people who've been to Montana, it's a beautiful place, and the bears are going to be really happy when they start drinking. But what it says is that when you look at the future, I think of myself as a futurist in some part. It's not about what you're doing tomorrow. It's not about the hardware that I happen to be building. I'm just a conduit. What it is what you do with that. And somebody's going to look at this, and a group of somebody's going to look at this, and they're going to start saying, where should we buy, how should we develop, where should we go? And that's going to change the perception. And there are dozens of these kinds of apps that are being developed right now. And I call them apps. They're not things that you click on your iPad, but they're similar in the sense that it's people using the data in a different way that's going to change the way that we see the future. And one of my favorite sayings, and because I have a propensity to fail a lot as we go forward, is that you have to do that. You have to be able to put yourself out there. You have to be able to feel that risk and that pain in order to really feel the success. And what you try to do, as much as possible, is not make the same mistake over and over again. But this is a process. Everything that we're doing in human spaceflight and the way of building infrastructure is part of being a failure. You have to fail in order to be a success. So many of you know the history of the Mars program, but I use this picture because I love it, and I imagine those of you who've ever tried to pitch a proposal or raise money or do something, if you said you got a group of really smart people like I have here, and I'm going to come up here and I'm going to tell you that I'm going to take your $1 billion rover and I'm going to put it in this really big beach ball. And I'm going to take this really big beach ball and I'm going to throw it out of a spaceship. It's going to hit the ground on Mars and it's going to bounce, 5, 10, 50 times. And at the end, it's going to land in a place that's going to be good and it's going to open up and the rovers are going to drive off. And don't you want to invest $1 billion in me? Anybody? I'm obviously paraphrasing, but that is sort of what happened. And this is the actual test device that was used for Spirit and Opportunity. And I think if you just looked at that as a statement, somebody would have said you're crazy. And they probably would have been right. But it worked not once but twice. And having been part of those two programs, their mission life was under 6 months, and one of them is now into its 9th year. It's doing pretty well. But it took some pretty crazy people to come up with this idea. And those crazy people didn't go away. They figured out that maybe the next best way to do this is to build a rover that couldn't go into a big beach ball anymore. So it had to figure out a different way to get there. And I think many of you are clued into the whole how did we get there, but my company was part of this program, and we did the last minute of the 7 minutes of terror by helping the vehicle lower itself to the surface. So we were posed with the problem that you want to take this vehicle, ride it for 340 million miles, 9 months, and at the end of this cycle of coming all the way to the Earth, you have about a 10-second window that you have to hit. If you come down too fast, you destroy the rover. If you come down too slow, you're probably going to be blown off course and it's not going to hit right. So imagine the precision that had to happen, not through just my company, but the whole team. But that was a pretty crazy, audacious thing to be thinking about doing, and obviously it worked. But what I'd like to show is just my favorite video of this, which I think talks about where were you when this happened. So if we were to fail, we would have failed in front of about 400 million people watching this live on television, or at least as live as it could be.
He just separated from the ground.
Because about right now, I finished my last Valium for the day. And it's the last few seconds of that video that I think I love. It's not just the technology of what we did, but there are people who worked 8, 9, 10 years of their lives for that moment. And that passion of being able to see yourself succeed in something that was as audacious as anything that we've ever done as humans, in my view, was an amazing feeling. And I think that's what we're seeing more and more in this industry. But it's more than that. What's the app from this program? It's all the knowledge that we'll learn about what happens on Mars. This is an actual picture of one of the activities of drilling into the Martian surface. And that's amazing, and it is what we do, and we are so thrilled by it. But it's more than that. It's what do you do with the ability of what you just put together on this? And you need to think out of the box. When one's developing the future, when 2020, what is this going to look like? In my view, some of the things that come out of this are not anything related to Mars. I think one of the biggest things that's going to come out of it is this. If I could take that Mars arm and I can pick up a pebble on Mars from 340 million miles away and do that constantly for years, that technology, that software is now being ported over to the medical industry, to the device industry, to the prosthetics industry. And how many people are going to be helped by that? How many people can take this energy that's being used in the space program and move it elsewhere? The apps from the Mars program are going to be things like this that are going to change what we do here on Earth. We are very fortunate to be at the forefront of human spaceflight, not only with the Virgin program, but with our own program, our orbital space vehicle called Dream Chaser. And one of my other favorite sayings is on the bottom there, and say some people say and look at things and say why, and I look, and many of us look at things and say why not. When we first started this program 9 years ago, we were basically had a team of about 30 people in a garage building in San Diego. And we went and said to people, we're going to someday build a replacement for the space shuttle. Sort of like the audacious, we're going to drop your Mars rover in a big ball, or we're going to take this, the whole Mars program that's as big as a car, and we're going to send it to the surface. And I think it's that kind of feeling. Everybody in the world basically said, you've got to be crazy that you think you're going to be able to do a follow-on to the space shuttle with no people and no money and really no program at that time. But we believed that there was an opportunity to do this, and we felt that what the space shuttle represented was something that was magical and shouldn't go away. And we persevered over very slowly, very, very quietly for a while, and made a lot of mistakes over time. But I'm very pleased to be able to say that that dream is well on the way to making that happen.
With its wings and tail structure removed and shrouded in plastic wrap, the test vehicle arrived at the California site following a 5-day, 5-state journey from the company's facility in Louisville, Colorado. The vehicle undergo flight and runway landing tests tried in collaboration with NASA's Commercial Crew Program.
So we have built and delivered our first full-scale, full ready-on flight vehicle to start its testing. And I'll tell you, I've landed things on Mars. I've done an awful lot of things. Probably the most traumatic thing beyond landing on Mars last summer was taking this vehicle that took 9 years and an awful lot of time, money, sweat, and effort, wrapping it up in white Mylar, putting it on a truck, and shipping it across the Rocky Mountains. The calls that we got about what was that thing that was going down the highway, and it was pretty fun. But when we started shipping it, living in Colorado is a beautiful thing to do, and it's a great place to live, and I love it. But we're prone to having some sudden snowstorms on occasion, even as far into May and June. And we had one of those when this happened. And you can imagine the trauma thinking that this is a one-of-a-kind vehicle now on the back of a truck going through the Rocky Mountains somewhere and dodging animals as it went by. And life, you don't really realize how traumatic life can be. It's the little things. But we're very pleased and proud to be doing this in a very unique way. It's not just us. You saw we've delivered this to the NASA Dryden Center at Edwards Air Force Base. We have the Air Force helping us, we have NASA helping us, and we're doing it. It's a unique public-private partnership that this program represents in so many ways. This is what it looks like now after many years of work. It's a full-on vehicle. It's been going through its ground-based tests now. We call them tow tests, and it's very shortly going to start its autonomous flight program. And after many, many years, whether or not we win the next level of the competition or not, just the idea of being able to say that you've gone from this thing in your head to something that is now built and going to be flying here shortly, I think is what we all feel, and the reason that we're in this industry and why we're so positive about it. And I think it goes back to the beginning. You know, when did you know? And many of the people here are just coming into the industry, and I like to tell them that it is about passion, and it's about passion for me, and it's about passion for John Glenn. He doesn't feel any differently. I don't feel any differently than when I started. But there's a little bit of a trick, and if I could pass on my own piece of personal advice, you get really crazy in this industry. You can go up and down. Congress, you never know what they're going to do from day to day. Programs get canceled, and you can go pretty nuts. So what I try to do is find a little place in myself that takes me back to remind me why I do what I do. And for everyone, it's different, and all I can say is find the thing that makes you feel the best and keep that to yourself and be able to go back and forth as you need to. And my little place is this. That's me up in the upper left-hand corner when I first started learning to fly. And I go back there to the family farm that we work on, and that same airplane is still flying, and that's one of the things that we love to do. It's not about, when we go to orbit, we'll be going about 17,500 miles an hour, which is about 5 miles a second. I'm lucky if I get 5 miles every 5 or 10 minutes out of this particular plane, but it's about feeling that passion and going to find a place where you can really enjoy yourself. And this is about an industry gathering, and I always like to talk about how this all started. And real change comes from real partnerships, and nothing I've done, nothing I do can be done without a terrific team of people. We have dozens of companies supporting us, NASA, the government, and many other places. This is the very first photograph of what I think is the very first gathering of an aerospace industry meeting. It happened back in 1907, and it was put together not by any of the big famous names at the time in aerospace, not that there were many, but it was put together by Alexander Graham Bell, who's sitting in the middle there. And he and his wife Mabel did two really important things. They started the first X Prize. They put together a prize to attract the smartest, youngest people in the country, or in the world at that time, but mainly in North America, in Canada and U.S., to look at the problem of how do they make airplanes practical? How do they make them work? And the second thing he did was he started the first industry association for aerospace. And this is a man whose history came from making the telephone and other things like this. But he was someone who looked at it and he said, my job here is not necessarily to do everything. My job is to be the catalyst and bring people together. And they did that, and the plane in the bottom left is the one that they put together. And what was significant about that plane was the Wright brothers had a particular problem when they flew, and that was it couldn't turn very well. And it's pretty hard to be in an airplane if you can't turn. So they had a bit of an argument back and forth between Bell, who thought he had a different way, and there had been other people looking at different ways of handling it. The Wrights didn't go down that road. Bell decided that he was going to do this competition. He reached out to a lot of smart people around, and I'm paraphrasing the story, but the end result was that they began popularizing and bringing to the forefront what we now have on airplanes: ailerons, flaps, rudders. Instead of trying to change the wing by making it look like a bird, which is what the Wrights were doing, it's called wing morphing, they went a different way, and frankly got the last laugh, because every airplane that's ever been built, virtually, has had that type of device in it. And he didn't do it because he was the smartest person or because he was even an aerospace engineer. He was just someone who realized if you put a lot of smart people in a room, you can get good things done. And I think that's the way we'd like to see our industry go. And I oftentimes close with this because I think it's a symbol of how we've viewed growing the space industry, and it's a quote from Gandhi that said, first they ignore you, then they laugh at you, then they try to fight you, and then eventually you win. And I think as I talk to people, I say, keep your ideas. Everything I've showed you today on these slides were pretty audacious ideas that no one would have given anybody any credit for even being able to do, mine and others. And if you stick to what you believe in and you keep your passion going, good things can happen. So I'm going to end with my favorite photo from the shuttle program. And I look at this because I want to say that as we look forward to the future of our industry, it's not about the tools, it's not about the infrastructure that I'm building, it's what you do with it, and how do you apply it, and how do you make what we do really matter in the world. And you look at this picture, you can't tell where these people came from, what company, whether or not they're government, or whether or not they're industry, what race, creed, or color they are, what geographic area they came from. They're all people who believed in the success of something, and that's what really drives this. So thank you for listening. I'll be happy to take any questions.
Yeah, I got a... Hello? Yeah, I got a question about the rocket motor 2. Has that thing ever been fired for the full duration, full size, full duration firing? And do you have confidence it's got enough power to get SS2 into space with a full load of crew and passengers?
The answer to the question is twofold. The first is, yes, it has, but on the ground. And in any type of airplane or space plane development program, you do it incrementally. You want to be able to understand how this all works. And in fact, even with the Dream Chaser, you work backwards instead of dropping and flying. And I'll tell a little bit of a brief story. My grandfather, who taught me an awful lot about things like this, he said the most important thing you ever get out of flying, the most important thing you can do, is have an equal number of takeoffs and landings. Everything else is not relevant. So we actually take that to heart because we learn how to taxi first, we learn how to land second, we learn how to fly third, and we learn how to take off fourth. And so the program now is moving forward. The motor system obviously worked, and we'll be expanding the envelope, we call expanding the envelope, expanding the duration shortly.
Well, what is, just two quick questions, what is the actual firing time for full duration, and how many times has that been done?
I actually can't answer that because that's a Virgin answer, so I'm part of that team, but you'll have to direct that to them. It's proprietary information for them.
Okay.
Over here.
Yep.
Hi, Josh Jenkins, Virginia Tech, Aerospace Engineering.
Hi, Josh.
With the apps that you mentioned for the Mars Curiosity landing, for the Dream Chaser program, what apps do you foresee in the future resulting from the program?
Yeah, it's a great question. Certainly the one that's getting all the notice now is the transfer of crew and critical cargo to the space station. But the whole reason we went into this was because we're trying to design a utilitarian vehicle for space, a vehicle that can do other things. And what are some of those other things? Well, we saw one with the shuttle, which was fixing the Hubble telescope. And something like 85% of the pictures from Hubble came after some very brave people, and the space shuttle went up there to fix it. So we think we can do servicing in space from the vehicle. We have the capabilities. We think that we can transfer people to other destinations should they be built. We think that this is a pretty good science platform. One of the big challenges for the work that I do and we do is that it's a chicken and egg story. You build something new, but you can't get heritage on it because you can't fly it. And so how do you get heritage on it to go fly it? So that becomes a big problem. And one of the things the Dream Chaser might be able to do, and we think it's going to be capable, is taking some things to space, bringing them home, and getting them some heritage in space. But the bringing them home part is a really special part about this. We come home to a runway landing. We need no more space than a 737. We come home at less than 2 Gs. So whatever we do in space, be it bringing people home or bringing critical experiments home from the space station, we heard a little bit in a previous discussion about bioscience and things going on in space. Bringing that stuff home is as important as doing the research, because if you find something really wonderful, you want to be able to get it back and exploit it. Or if someone is sick or injured in space, you want to get them home. So the idea of being able to do real science, real development in space, it's being done on the space station, but it's pretty hard to get on the space station, and it's pretty full up, and maybe someday it won't be there. So we see ourselves as a pretty good science platform for those kind of activities as well. Okay. Well, thank you very much for listening.